All right, this is the example of a mass spectrum. I've kind of got it at the end of the Jamboard, so I'd kind of go to the end. So let's take a look at this and kind of get an idea of what you might have to do on a test. This is really pretty straightforward. So example 4 here says to deduce or to find the relative atomic mass. So when you see the term relative atomic mass, then we're looking for that periodic table number. So it's that value on the periodic table for the mass. And so we should expect to find a value that is an average. Remember, the other name for this was average atomic mass. So if we look over at this data, it says, okay, from the mass spectrum, so this right here is the mass spectrum. That's the piece of data that the computer is going to give after you put the sample in. Now, this is a pretty straightforward one, not a very complicated sample. And then it says at the end, it says to go ahead and identify the element. Okay, so let's look at this. We have a couple of options. We have percentages over here, but you don't always get percentages. Okay, so we do have them here, but you don't always get them. So this one here is 77%, and this one here is 23%. Okay, now I'm going to show you how to do this mathematically, and then I'm going to show you how to do it. Actually, I'll show you how to do it without math, and I'll show you how to do it with math. So if we're going to do it without math, so you don't have a calculator, you have a mass of 85 and a mass of 87. So the average has to be between 85 and 87, because remember, we are finding an average. So it's got to be between the high 87 and a low 85. Now, if you look, this is the big line here. So the big line, wherever the biggest line is, that's where the bulk of the mass is. So the bulk of this thing weighs 85, but it also has a line here. So since there's a line in front of it, although it's not as big, it's going to pull the average this way, all right? So it's still going to be 85, but it's not going to, it's going to be pulled a little bit above 85, all right? So if I'm looking at this data, well, it's not going to be pulled all the way to 87 because this line is pretty small, and it's probably not going to even be pulled all the way to 86. So I would guess that this would kind of land somewhere in this area. So I would guess something like 85.5. Okay, so that's what I would guess. Now, let's go ahead and take a look at it mathematically. Mathematically, we're going to, so this is our non-mathematical number, 85.5. So that was our guess, okay? So then let's do it with the mass. So we're just going to take the mass and the percents. So there's the percent, there's the mass, multiply them together. So let's go 85, and we're going to multiply that by, in a calculator, 0.77. And then add that to the 87. And we're going to multiply the 87 by 0.23. Now, like I said, you don't always get the percentages, so you got to be able to kind of inspect them as well, not just use the math. So let's do this in our calculator. So 85 times 0.77, hit enter, and then add that to, in parentheses, 87 times 0.23, run it through, and I got 85.26. Oh, sorry, 85.46. So now I got to figure out what element this is. Okay, so don't have my periodic table, so let me pull that up real quick. Okay, so got my periodic table now. So what we're looking for is we are looking for this mass on the periodic table, or as close as we can get. So go to the periodic table, and so let's look for a mass value. And so there's 79, there's 83, there's 85.45, and there's 87.46. 0.46. So strontium's 87.62. Rubidium is 85.45. And the krypton is 83.80. So we're going to go with the rubidium because it's 85.45 and we got 85.46. So we're going to go ahead and go with the rubidium because that was the closest. All right, so we picked that because it was the closest on the periodic table. All right, so let's take a look at this one down here. Why don't you guys try that one on your own? You do get percents, so you can do the math if you want, but you should also try it without the math. Try it without the math and see how you do. All right, so hopefully you got it right. Hopefully you tried it. You need to try it. Otherwise, you're just kind of writing down what I'm doing, not really learning much. So once again, we're going to figure out this element, and we're going to get the average atomic mass. So we've got a value here. So we've got one here and one here. So now you got to kind of look at them. I think you could pretty much, it's not a very straight line, but I think we could probably pretty much say that it's a 60-40, right? Like that looks pretty good to me. And so I'd probably say this is a 60%. I'd probably say this is a 40%. Okay. Now I'm going to do it without the math first because you need to be able to do it without the math. So assuming you didn't have that. So here we go. We got the 69 and the 71. So I know that it's near 69, but it's also getting pulled towards the 71. So if it was the same exact size of line, then it would land on 70 because it would be dead in the middle. I think what's going to happen here is it's going to be a little bit behind 70 because of the size of the line. So maybe 69.75. That might be a decent guess. So I'm going to write that down as my guess. And then let's go ahead and do the math and see how I did with my attempt at getting it without the math. So 69, I'm going to multiply that by 0.6. I'm going to bracket that. We're going to add that to this side is going to be 71. We're going to multiply 71 by 0.4. So I'm getting the mass values there and the percents there. All right, so let's go ahead and see how we did. Get our calculator out, 69, multiply by 0.6, and that's going to equal a value that we're going to add to, in parentheses, 71 times 0.4. And the value I got is 69.8. That's pretty close to 69.75. So we did pretty good on guessing. I mean, we weren't guessing. We were making we had a plan, right? So we weren't guessing. So let's go back to the periodic table. So we're looking at, what was it, 69.8. So find a mass near that. So here's gallium, 69.72. And germanium's too big. Zinc's too small. So it looks like gallium, 69.72. Usually there shouldn't be a lot of choice here because the gallium is the 69.72. So then that is about as close as we can get to that. So that makes sense. So there you go. A couple of those. All right, so let's go on to the next one. The last, actually I got to go all the way back. Okay, this one is back to where we want to be for that last example. So example 6, you can try this on your own. It's a bit of a tricky one, but you can give it a whirl. All right, so what's going on here? They're asking for what are the two isotopes in bromine, and bromine is diatomic. That's a key thing there. And so it says there's 5 values in the mass spectrometer, and there they are. There's the 5 values. And so we have got to figure out what the bromine is made of. Okay, so here's the thing. Bromine is diatomic. And so what that means is that when you put bromine into the mass spectrometer, you're going to get some of the masses will be for individual bromines, but some of the masses are going to be for these diatomic bromines. Okay, so for the diatomic bromines, they would have 2 bromines. So the diatomic bromines are represented by the 160, the 158, the 162. Those are the diatomic bromines. So those are the bromines that did not split apart. So we're interested in the individual bromines. And so the 79 and the 81, that's what we're interested in because those are the 2 isotopes of bromine. So it says, what are the 2 isotopes of bromine? Well, the individual bromines weigh 79 and 81. If you stick 79s and 81s together, the combinations you're going to get would be a 79 and a 79. So a 79 times 2, well, that's going to be the 158. And then a 79 plus an 81, that'll get you the 160. And then 2 81s, of course, that's going to get you to 162. So that's what these values here are, okay? So the other question says, what's the relative atomic mass? Well, if I go over and I kind of clean this up a little bit, it looks to me like those lines are in the identical spot. So it looks to me like it's 50-50. So half of it's 79, half is 81. So it's 50-50. So if we have, 50% looks like it's 79 and 50% looks like it's 81. Well, it's logical that in between that the BR is going to equal 80. So that would be the logical answer, is that halfway between the mass would be 80. So example 6 is a little more complicated than you actually need, but still gives you some good information on mass spectrum. So once again, on the test, what do you got to be able to do? Be able to read a mass spectrum, which is this guy here, and then tell me what element it represents. So your previous examples 4 and 5 are really the best for studying for that. So I'm going to pause it here.